So exciting time. We are ready to talk about the final project, your way to prove that you have learned what you were expected to know for this class. Now, it's very common at this point for students to be a little worried, even scared, because maybe you've gotten a lot of help up till now, and you wonder whether you can do it on your own. Well, let's start by talking about the kinds of questions that it's okay to ask. The blue ones here, how do I know if there's an interaction? How do I explain a categorical effect? Those are examples of conceptual questions, topics that we have talked about in class. And if you want someone, either me or someone on a discussion board or a TA or one of the tutors on that web page that's for hire, that's great. Ask them to teach you these kind of things if you're feeling a little shaky on it. Or R code questions, how do I get multiple lines on a graph? Notice you're not asking them to code your data, just in general, what are the R commands that are done for this? There is one exception to these general overall types of questions that are okay to ask. If you have code, notice the implication that you've already made some code and it's giving you an error, it's okay to ask, why am I getting this error? How can I fix it? Someone will come along and look and say, oh, look, you forgot to capitalize T on temperature. Of course. So this, if you already have code and you're getting an error, then you can ask and someone can help you try to figure out why it's giving you that error and fix it. Not write the code for you, because that's part of what you're expected to be able to do in this class. So what kind of things should you not be asking? Why do my residuals look funny? Should I use a quadratic or log? Those are things where someone has to look at your data and look at your patterns. In general, the answer would be, it depends. It depends on what scenario you're in. So if the question is, it depends, let me look at your data, then that's not the right kind of question. You need to be doing that yourself. How do I explain this particular effect? Well, I can talk to you about how to explain categorical effects in general, but not your specific example because it's your final project. Do these residuals look okay? That's a very common question. You have to be able to make that judgment call. Now over here, these two are a little different. If you're asking someone to help you rewrite it or fix what you have said that's wrong, then that's not okay because you need to show that you know how to talk about it, not that somebody else knows how to talk about it. On the same hand, I've had, for example, foreign students who struggled with English, and I've told them, find someone who doesn't know statistics and read what you've written to them. Not only does reading it out loud help you to see whether what you're saying makes sense, but also they have a chance to say, no, I don't get that. Now, if they're just saying yes or no, that's not doing the final project for you. They're just saying something's wrong, I don't know how to fix it, but you need to keep at it until it makes sense. So it actually is okay to ask someone who doesn't know statistics, does this sentence make sense to you? And in fact, that's a great practice for how to explain things. But it's not okay to ask someone who's in this class or a TA or a tutor, can you help me write this or rewrite it so that it's correct or makes sense? Now, I've just finished saying questions you can or can't ask. You are allowed to ask me anything. Just understand that I may not answer it. I very well might tell you, that's a good question, that's something you need to show. So let's take a look at the actual final project, which is supposed to be fun because we're talking about this fictitious war and how could we get more enemy casualties but fewer civilian casualties. Some things to notice. Here's all the different variables, and yes, this is a little bit bigger than anything you've ever done before, but the principles are the same and the patterns are the same. So having a lot of variables here should not scare you. There are two y variables, which means I'm going to make you do this twice. It's really nothing more than a sneaky way of making you do it one way and then do it another way. So you have to have a model to predict enemy casualties. Your goal in that case is to maximize and also do it again for the civilian casualties. In that case, your goal would be to minimize the civilian casualties. And you've got all these different variables. Two of them are categorical, that's terrorism and the mysterious IG88 variable. The others, they might be linear, they might not be significant, they might be quadratic. It's different for every student. I have a program that randomizes which variables do what, and because the variability is also randomized, sometimes you'll have one variable which has some particular effect, like let's say it's quadratic, but the effect is so small and the variability is so high you can't tell, so you don't always know that you're going to get a little bit of everything. And that helps me test whether you're actually comfortable digging in with this data set. You don't know what effects are going to be doing what, which is realistic to what really happens when someone brings you some data. Now, the client in this case is actually 4 different people, these 4 generals, and each one has a different aspect that they want you to look at or make sure that you have in your report. And so General Dilpa here is the least statistical of everyone on this committee, which is why he or she, I guess it's a little vague, but wants things like the R squared, which as statisticians we know how dangerous that can be, but still you should give the client the R squared if that's what they are looking for. Also, this person's going to need some good explanations of what errors did you find, did you do nonlinear transformations, what about those categorical variables, and explain interactions, which is going to be hard for this one to understand, but hopefully we've talked about it enough. Model selection, how did you handle multicollinearity? Probably wouldn't be something that a non-statistician would understand, but how do you handle so many variables? How do you decide which ones to throw out and which ones to keep? And then have an explanation and make sure you answer the question. The question is, how can we maximize enemy casualties? How can we minimize civilian casualties? And for this class, you can actually treat those 2 questions separately. Some variables will raise both of them or lower both of them, which makes them tricky to decide what to do. You can treat them separately if you want. If you're willing to tackle them both together, it's very impressive. The second general in this committee has had a little bit more statistical knowledge, and so they understand that when you give answers, those aren't exact answers, there's always some error. So he/she is going to ask for some confidence intervals and also a prediction. And this is a really fun part of the project when you get there. Once you have a model that works well, use it to predict the first line of data. What I mean by that is if I look at my first row of data here, and I realize that in the browser it didn't line it up nice, but my enemy casualties was 2,904 for this particular scenario. It was a scenario where 955 was the stock value, terrorism was low, firepower was 0.25. So plug all these values into your prediction equation, and you should get a number pretty close to 2,904. And if it is really close, you're going to feel all happy about yourself. If it's not, that might be an indication you've messed up, which can help you find problems or errors in your model, or maybe you'll need to be able to explain what's causing the variation that's larger than you expected it to be. If this was a expensive project where someone was paying you $15,000 to analyze the data, you would probably do confidence intervals for every single beta and every single answer you give. I think that's going to be a little overkill on a final project. So we're going to pretend this general just says, find one of your betas, one of the slopes where it was a small number, and make a 95% confidence interval. If it's significant, that 95% confidence interval won't include 0, even though it was a very small slope. If it does include 0, that's informative. They might want to understand why you would have a variable that's not significant in your model. We've talked about lots of reasons why you might do that, but make a confidence interval for one of the slopes. That's for the enemy model and for the civilian model. The idea being that it'll help this general to see what kind of range and error and accuracy you have in your results. The third general is the very statistically minded one. This is like what your teacher needs to see to grade your final project, right? I want you to have an appendix and show me that computer output. That way, if something's really wrong, I can try to look through the computer output and see what happened so that I can grade whether you've actually messed up or there was some funny non-statistical problem that you were facing in your data set. At least that's the explanation your teacher's going to give. It looks like this general is going to give the explanation that he's trying to check if you're a spy, which I think is funny. This last line is just because some people might say, I'm going to include absolutely everything in the model so that I can get the best predictability. And this general is saying, no, don't do that. Go ahead and make this a smaller model so that the non-statistical general can see what's going on and not get confused by having 50 different terms in the model. And this last general is just setting up some of the rules, some of those questions I put on the board earlier. There are certain questions you can ask about concepts. You can even ask other people in the class about concepts, but you shouldn't have someone else doing your code, looking at your data, or figuring out what the right thing to do is. You can ask me. The TAs are going to be well versed on what kinds of things can be done. And here's that special line I put in just specifically thinking of foreign students who struggle with English. If you ask someone who doesn't know statistics, does this make sense? They can say yes or no, and saying yes or no doesn't write the paper for you. You still have to figure out how to fix it. This last page is, in my opinion, really the most important. Here's the rubric. Most students who do poorly on the final project didn't go through the rubric in detail. Why is that? Usually because they're burned out towards the end of the semester and they don't want to, but here it has everything that I'm looking for. Is it readable? Here's where I'm looking at the English. Is your intro good? Does it grab your attention? Did you find the errors and fix them? And then for each model, I want you to describe just the distribution of enemies. So maybe a histogram, maybe a summary or box plot. There's lots of ways that you can talk about the kinds of deaths for enemies. Does it range from 2 to 12 or does it range from 200 to 12,000? That could be important for a client to know. Explain to me how you picked the model you used and go through each of the variables. Even if you drop a variable out of the model, the client deserves to know you dropped it out for a reason. And what does that mean? Basically, that this variable shouldn't be used to predict the response because there's other variables that do it better. But have that in there. Make sure that that's mentioned. You should be justifying with residuals. We've hammered that one a lot. Talk about S and R squared. Here's what that one general specifically asked for, the confidence interval for one of the betas. I don't particularly care which beta you pick. I think if it's a small one, it's a little more interesting because you always wonder, is 0 going to be in the interval? Talk about the prediction equation. If you know how you're going into this war, can you predict how many people are going to die? And do the prediction for the first row of data as an example of how well it works. And this one's really important. It's also a very common one to get left out. If I want to kill the most enemy soldiers, what do I do with my variables? And same for the civilian side over here when you get to the end. If I want to not kill civilians, what variables should I use? Should I use lots of bombs? Should I use few missiles? How do I minimize civilian casualties while maximizing the enemy casualties? Now this stuff down here is often a repeat. If you did a good job of explaining these variables, that means you already explained the linear effects and the log and the polynomial and the categorical. But when I'm going through the rubric trying to figure out what parts of this class are you still struggling with, sometimes it's there was one particular item that you struggled with and so I can mark it here. Sometimes it's every single time you had a linear term you struggled with it, so I can mark it down here. So the rubric is long, not because you need a paragraph in your report for every item here, it's because I need to be able to distinguish exactly where it is that you are struggling if you lose some points. But when you do a linear effect, you should be able to use the number. Logged effects, you should be able to talk about the percentage change. Polynomial effects, it gets a little harder. Using the numbers, like the value of the x squared term or the value of the x term, that gets harder. So a graph is good as long as you have an explanation to go along with the graph. Categorical effects, you can use the value, but when we talk about interactions, there's two different ways. You can talk about the values or you can just talk about a graph, and that's fine. I'm okay with whatever you're comfortable with. Numerical interactions, you need to have a graph because they are complex without a graph, but also a description, and sometimes it's hard to describe what you're seeing with those interactions. When you do the confidence interval, you need to be able to talk about it correctly. If you didn't pick that up in the intro class, I'm hoping you picked it up in the methods class. And when you did the prediction, which was clear up here, it makes sense that you would have a note to say, here was the actual value, here's my predicted value, and then comment. This was really close. I feel like this is a great model. Or it was really far off, and here's what I think was happening. And when you make the conclusion, it should be both interesting to the person reading it and summarize everything we've done so far. And that first general, the one who's not a statistician, if there's stuff in that report, you need to explain it. So don't have output that you've just copied and pasted from the computer. And in the appendix is where you can put that. So yes, you'll be copying and pasting stuff from the appendix. I want to see that summary from the LM statement. I want to see the residual plots by each variable. And then it's easy for me to flip back there and see, okay, yeah, these residuals all look good. You have a good model. I can see the numbers you were working with when you were trying to describe stuff. Okay, it looks like you correctly were able to analyze the data. And sometimes there might be problems in your residuals, and I can go back through your report and say, they acknowledged right here that there was an issue, and here's the things they tried to do to fix it. And in the end, this was what they decided was the best model. Okay, my goal isn't to see whether you got the model I got for your data. I actually do make models for your data, and sometimes I look at them, but you do not have to have the same model that I do. but you do have to have a good model that shows you understand what we've gone through in this class and that you have a good reason for picking the model that you finally end up with. So there's the bottom line for the final project. In the next video, let's go through a list of steps that I would expect someone to go through when they're trying to analyze a big data set, like, for example, the final project.